we see that CO has a charge of 2 or 3, so it could be either or, so this was actually kind of a bad example. But in this reaction here, you can see that the 2 is behind the OH. Then we look here, we know OH minus has a charge of -1, so they happen to be using CO2. So we can say CO. Like that, right? So that's where this comes from. So the 2, remember, is the charge on the CO. OH has a charge of -1, so you don't see it down here. And then the NaCl is just like the example I just gave you. Now you notice that there's subscripts, or not subscripts, there's coefficients here, so we need to balance this out. Oops. No. So we have to balance it out, and we just do that by adding those coefficients. So we do that here, 2 and 2. Now there's 2 sodium over here, 2 chlorides over here. 1 cobalt here, 1 cobalt there, 2 OHs, 2 OHs here. So that's how this comes about. Now, the complete ionic equation basically goes into this whole thing that this is going to dissolve, this is going to dissolve, right? So in our water, we're just going to have CO2 plus, Cl minus, Na plus, OH minus, and remember, we're going to have we're going to have that. So in our reactants, our complete ionic equation is going to consist of exactly that. 2Cl minus, 2Na plus 2OH minus, right? And this is just that up there dissociated, right? So in our reactants, that's what we actually have. They break down into different components. Then in our products, what we have is normally the same thing. So we could have COHS, or we could have cobalt hydroxide or sodium chloride. But this is where you have to make sure of these rules. So the NaCl, we already know, and I showed you multiple times. Oops, that's not the right thing. This one. That this breaks down in water, so we already know that that's going to happen. So we could say plus, Na plus, and there's going to be Cl's floating around. Okay, now we look for the cobalt hydroxide. So we look at rule 1, which talks about NO3s. We don't have that, so we look at rule 2, talks about alkali metals and NH4. We don't have that either, and we keep going down until we get here. So most OH ions are only slightly soluble, and BaOH2 are marginally soluble. So basically what that means, marginally or slightly means you would have COOH2, and if it dissociated, you get that, right? But what it's saying is, say, this is just an example, I don't actually know the real number, but most of it is going to be in this form, which is the solid form, right? So this is why you're saying this is solid.